Hello, class. In this micro lecture, you're going to learn more about valence electrons of the main group elements. In this section, the aim is to help you understand the electronic structure of the elements. Valence electrons for the main group elements. The last filled energy level is called the valence level or the valence shell of an atom. The valence level contains electrons that are highest in energy and that occupy orbitals that are the furthest from the nucleus than those in the lower levels. So valence electrons occupy orbitals in the valence level, and all of the other electrons are called core electrons or inner electrons. If we look at the valence electrons for bromine, we would see that bromine has 7 valence electrons based on this electron configuration, because the outermost energy level, or the valence level, also known as the valence shell of bromine, is going to be the level at n equals 4. And there are two kinds of orbitals in the n equals 4 energy level, and that is the 4s orbital and the 4p orbitals. So if we add the number of electrons that are found at energy level of n equals 4, we would add the 2 plus the 5 superscripts, which gives us 7 valence electrons for bromine. We can determine the number of valence electrons in each of the following elements based off of their positions in the periodic table. We can see that fluorine is a group 7 element, so it has 7 valence electrons. Lithium is a group 1 element, so it has 1 valence electron. Sodium also has 1 valence electron. Carbon has 4 valence electrons since it is in group 4, along with silicon having 4 valence electrons and lead having 4 valence electrons. So elements that are in the same group have the same number of valence electrons. So now that you've learned more about the valence electrons of the main group elements, you may have noticed that many of them share the same number of valence electrons. Well, moving forward in a future lecture, you'll learn more about how using that number of valence electrons for the main group elements can help you predict some of their chemical properties.